Okay, here's an example of some synchronous TDM, but with various input data rates. Okay, so we've got two inputs at 450 kilobits per second and three inputs at 900 kilobits per second. And we have no framing bits and we have no empty time slots, and so we are asked to figure out how we can design a frame here. And eventually it asks us to assume bitwise interleaving here. So let's draw a picture of two 450s and three 900s. Didn't leave much room for it, but there they are. And let's call these A, B, C, D, and E. And let's go ahead and design a frame, and let's imagine that in the time it takes for one bit to come in at a rate of 450, that for the 900 is twice the data rate, so twice as many bits came in at 900. And that means we can design a frame that looks something like this, with an A and a B, but then the C and the D and the E are coming in at twice the rate, so I get two of them for every A and every B. And so there's a frame design that should work. And our A's, B's, C's, D's, and E's up to this point could stand for a byte or a bit. As I say, eventually they're going to ask us to do bitwise interleaving. And with no framing bits, the multiplex signal rate, our total, is just going to be the sum of the input data rates. Sum of the input data rates from I equals 1 to 5, let's say. In any case, it's twice the 450 plus 3 times the 900. So that's a 900. 4 times 900, 3600 kilobits per second is, or 3.6 megabits per second. Okay? Yeah, 4 times 9 is 36. And now if we assume bitwise interleaving, then the number of bits in a frame is going to be equal to 1, 2, 3, 4, 5, 6, 7, 8 bits, which is 1 byte. And now let's calculate the multiplex signal's frame rate. Well, we know that the frame rate is equal to the rate of one of the inputs divided by the number of bits. If they were all the same size, we use this formula where n is the number of bits from one source in the frame. So if we use bitwise, we have n equals 1. If we use bytewise, we have n equals 8. So it's the number of bits from one of the sources in a frame. But now our R's are not all the same, and so instead what we're going to do is we're going to say it's the data rate from source number 1 over the number of bits from source 1, and it's supposed to equal, no matter which of the 5 input sources I have, I'm supposed to have equality here. Okay? 5 over n5. Well, n1 is 1, and that's also n2, and r1 and r2 are both 450, and so we get 450 over 1 for the first two. And for the last 3, we get a rate of 900 over 2, which is also 450. So this equation works, and for all 5 of them, we get 450 frames per second. Okay? No, it's 450 kiloframes per second. Let's carefully think about it, because all the R's are kilobits per second. Okay? So it works. And I hope this helps, and I'll stop here.